Please enter the meeting passcode, followed by the pound sign.
I'm just going to set you up.
Okay, perfect.
Are you doing?
Hi, Monica. Does that work?
Hello, hello, hello. All right.
I can hear you.
I think anybody who is on Zoom should mute themselves. Okay? All right. How's everybody? It's hot out there. Anyway, today we have an exciting class because we're going to be talking about projects. But before I do that, let's do a little bit of class logistics. The homework is due today. I hope everybody has done the homework. And we are putting out another homework, and that should be out within the next couple of hours, next few hours. Okay, so the homework in the second homework is based on the material we discussed in the last lecture, and you get to play with a live knowledge and task assistant, and you get to make one yourself as well. It is a very lightweight exercise, okay? It's not like you're going to do something very, very fancy, because we just want to make sure everybody has their hands-on experience with doing something. But that will, working with an agent. And what we expect is that after doing that, it will probably give you a better idea of what you can attempt in this course, what is easy and what is hard. Some students came up to me and said, "Oh, can I do this for my quarter project?" And I say, "Try it on GPT. If GPT works as is, then this is not a project." Okay, it's easy to try. Whatever you want to do, try it. If you can find problems with GPT, then you may have a project. So that's how it goes. So today we're going to talk about projects. This is the first day. We're going to devote quite a few days on projects, and this is the first day. And what we have done is that we have asked the people who are pitching projects to come in person and on Zoom to talk about their projects. It's a very short introduction to the projects. You can find out more information on the proposal, or you can talk to the people afterwards according to your interest. Okay. So let's get started. And the first up is Lynn. Is Lynn in there? Is Lynn ready on Zoom?
I'm here. Can you hear me?
Yes, we can hear you. So
Okay, great.
Let's kick that off. Thanks, Lynn.
Great. Okay, thank you, Monica. It's so nice to be here today. I've been really fortunate to have met Monica several years ago and have been working with her amazing team for a while. And I'm from the School of Medicine, so we've kind of combined. I do treatment for individuals with autism spectrum disorder. And our team has been working with Monica and her amazing team to work on some treatment for people with autism. So let me just go to the next slide. we have really seen an increase in the prevalence and incidence of autism in the last few decades. When I started in my career, it was 1 in every 2,500. Now, the CDC last year points to the fact that 1 in every 36 children are being diagnosed with autism, and this creates a huge problem. There aren't enough providers to deal with all these kids and adolescents and adults. They're not well, a lot of the providers aren't well trained, so the individuals aren't getting very good intervention. There's long wait lists for the intervention, and there's more research and services available to young kids, but not as many to adolescents and adults. So it's really a crisis right now for people that have autism. They also have the lowest employment rate of any group, any disability group. Most of them have very few friends, and most of them don't have very many social activities. So it's a real problem. And over the last few years, Monica's team and our team developed Nura, which is a web app program to help clinicians implement interventions that are usually face-to-face, but we've gotten these apps to be able to target these areas, which mostly are challenging areas for our folks. And we have modules that help with empathy, asking relevant questions, listening and responding, talking the right amount, not talking too much or too little, giving the right amount of personal information, not too much personal information if you've just met somebody, tactful responses, giving compliments, understanding sarcasm, which can be very challenging for some people on the autism spectrum, and also staying on topic during conversation. So we've developed these modules that can help in all these different areas. And we're very, very excited that we just finished a randomized clinical trial. It took us over a year to do, but we had 30 participants, 15 in the experimental, 15 in the control group. And we were very excited when we ran the statistics, and the experimental group showed significant improvements with medium to large effect sizes compared to the control group. And this was after only 4 weeks of using the app. And we started with a low dosage. We just wanted to see if we could kind of do a minimal number of trials. So all they had to do were like 10 examples a day, which could take, depending on the person, just a few minutes to a little bit longer, but just with a minimal practice, they really improved a lot. And what was also exciting was that almost all the participants rated the program as positive or very positive and said they would recommend it to others. We also, Monica and I, got mentioned in Scientific American article, which was kind of exciting because the article was basically saying that people were putting out all these things for individuals with autism, but some of them aren't scientifically proven to help them, and they could even hurt them. So it's kind of a risky thing, especially with a population that might not really fully understand that it's an app. And so we really are trying to not be their friend, but to give them really some positive skills so that they can more easily make friends and engage. So future directions, this next quarter, we would really like to increase the availability and just have this help change everything for people with ASD. We'd like to reach 50,000 people this quarter. In the US alone, there's over 75 million people with autism spectrum disorder. So we want to start getting to these people to really help and to create a mass feedback analysis system. And we also would like to look at some of the employment issues. There's a lot of these individuals, if they do get jobs, they have coaches that go to them to the job site, but most of them are not well trained. They don't really help them improve in communication. They don't really reward their attempts and things like that. So we'd like to develop another app that would really help them, help job coaches improve their feedback to the person with autism. So thank you. That's it for mine. My email is lynn.k@stanford.edu, but I'm sure Monica also has everybody's emails listed to get in touch. Great. Thank you so much. And we look forward to working with you if you're interested in this area. Okay, so I'll sign off. Should I sign off?
Question here for you. Can you hear me? Oh. Wait.
We have a question for you.
Okay.
How did you measure improvement?
Sorry, I can't hear. I think the sound is off.
Yeah.
Oh, I see in the chat. Let's see. What
Can you hear us? Can you hear us?
I can hear you now.
Yeah. Hi. This is my name is Shana. My question was, how did you measure improvement to compare between the experimental and control?
Oh, that's a great question. So we had a couple different measures. One measure is we just look at the app and see if they improved from their first week to their last week. And the second thing is what was more important to us was, does it generalize? So we had one of our team members call them before and after, and we looked at improvement. So we only had participants that had challenges at the beginning, and then we went through the treatment. And then we looked at their improvement score. So they had to score 60% or below. So we did do a conversation sample to make sure it generalized into everyday conversation.
Okay. I was just wondering how you designed the user interface in terms of how people were interacting with this app, and I guess how specifically it was helping them. Was this a conversation, like a practice conversation that they could use?
Sorry, I missed the last part. You wondering how we designed what?
Oh, sorry. This one is.
Okay, can you hear me now?
Yes.
Okay, great. Yeah, I was just wondering how you designed the interface. Essentially, yeah, how did the users use it, and what did you find was most useful to them?
Yeah, so I showed it briefly a little what it kind of looked like. So oops, let me see. I can show you what the app looked like. It's sort of, let's see, where am I? This is what our app looked like on the right. You can see it, Nora. And so, for example, for the empathy module, it might, Nora, the app might say, oh, I was running this morning and I twisted my ankle. It really hurts. And if the autistic person said, uh-huh, then it would say give feedback. Or if they said, oh, it'll get better, it gave feedback and it said, a better answer would be maybe showing that you care about my sprained ankle, like how are you feeling? So it would give feedback or tell the person if it had a correct answer. And if you're interested, I know we're short of time today, but if you're interested, feel free to email me and I can show you how it works in real life.
Becomes available. We closed it because of the clinical trial, and we make it available. And the short answer also is that the interface was designed as the way they, the therapists were, it's what the therapist was doing with them, with the patients, with the users.
Hello, my name is Kevin. Coming from the perspective of a psychology major, the conversation is inherently a multimodal form of it's multimodal. There's not only just the words that people say, but also how they say it, what the inflection is, body language, facial expressions, and these are also precisely a lot of the skills that individuals with autism may need help with. So are there any plans to incorporate this, and how do you, or just sort of, are there any things that exist right now that can incorporate these multimodal inputs?
You're absolutely right. There's a lot of kind of pragmatic areas too that are challenging. In this one, we've mostly focused on the verbal, and the participants were all able to carry on a conversation. So areas like eye contact and loudness and things like that. We didn't specifically focus on. This was more focused on just what kind of verbal response you give. But I did a couple of the language samples at, during the study, and I noticed a huge difference. Like on one of them, I said to the guy, "Oh, I twisted my ankle running," and he said, "I don't know what to say." And then after 4 weeks, I said something similar, like, "Oh, Lizzie broke her shoulder, or my friend broke her shoulder when she was riding her horse." And he goes, "Oh, I'm so sorry to hear that. Is she okay?" So really, we could see a big difference in most of the participants improve. So it was really exciting.
Do have to move on because we have
Yes.
many
Okay,
more
thank you so
talks.
much.
Well,
Feel
thank
free to
you,
contact me.
Thank you, Lynn. And
Okay,
just to
thank
add
you.
to that particular question, if anybody in this class wants to add multimodal to any of this interaction we have with people with autism, it is very welcome. You are welcome to do that. Okay,
That would be
so that would be
amazing.
a good. We talked about it, and it would be a really good topic to explore. There's a lot of technology that can be used. All right, thank you, Lynn.
Thank you. Thank you.
So we move on to the next speaker, and that is Trevor, and he is also going to be talking to us over Zoom. Trevor, please introduce yourself.
Hi, everybody. My name is Trevor Getz, and I'm an African historian. And I'm going to talk to you about African History from Below, which is a collaboration that the Center for African Studies is participating in, along with folks from this lab. And I guess what I really want to start by saying is that none of these people that you see in front of you historically appeared in narratives about the 19th century. But they're all people who appear in the African Times, which is a newspaper that was created by people of African descent in the Atlantic in the late 19th century. And we want to talk to them because history is a conversation that you hold with the past. And these kinds of people are historically marginalized. We hear about us. And in many cases, we don't need to hear about them less because they created things like newspapers and large data sets that there just aren't, there isn't the funding, there isn't the history of interacting with them. Unfortunately, what that means is that if you talk to ChatGPT or to a lot of other large LLM models, you don't get the perspectives and the stories of these folks. So we created History Chat, and it's based on this, or this instance of it is based on this newspaper, the African Times, which is an amazing newspaper with lots of history from the period, from the particular perspective of these English-speaking, mainly West Africans, people of African descent. And we took it in, we can browse it, we can search it, and now using Storm, it's producing articles. What we do is we want to see what these articles contribute that is different. We're not looking for right or wrong. We're looking for how the perspective of the people who wrote the African Times might be different from the perspective of people who wrote this thing, which is the UNESCO General History of Africa, which is a set of books. It's an older technology. It's from before, in some ways, people worked with corpora like the African Times. So the first thing we're looking for is people who can help us to analyze and interpret the differences and similarities, working with folks from African studies, and figure out why and how the African Times is giving us new knowledge and different knowledge. And if we can do that, we can start how this kind of thing is replicable and how different types of information from the past, from marginalized communities, from newspapers and documents produced by children or by women or by people with disabilities in the 1960s and 1970s or whatever, might become also a kind of source that we can communicate with to hear their perspectives and to learn them. So this is African History from Below, and the first of, I think, the two things that we're going to be presenting today. I don't know if anybody has any questions.
Hi, Trevor. Super interesting project. Could you repeat again what are the goals of what you're seeking? I understood briefly that you want to analyze what are the difference between the African Times relative to other media, or it's a different direction. Thank you.
Yeah, no, right. So we have some existing media, and so we want to prove the concept that that the articles that are produced through this LLM augmented tool can actually add to knowledge, can actually change the way we think the past happened, can actually give us a different perspective on the past. So the way that we want to do this is by doing a comparison between the articles generated by the African Times on certain topics and articles that exist or chapters that exist in pre-existing text source. And if we can do that, we can prove that this tool is adding to knowledge, right? Giving us a new and richer and different perspective on the past. So it's that comparison that is right now the thing that we think we can achieve in a short period. And I know Sina can also add to this explanation probably. All right.
Is going to be talking together with Sina on the next project, right? Okay, so let's get started. So this is Sina. Sina is is a senior PhD student in my research group, and in the very first class we talked about WikiChat. That is Sina's work, and there are many other papers that that you probably will be running across in the next couple of months.
Gonna shine light where it's never been. Shed the darkness.
That's a good background. So I just want to connect what you heard with what we have been talking about in the first class. We talked about the Bloom's taxonomy, where there are the basic understanding, and then if you look at the tip of the pyramid, it is about creation. And what we are doing with Trevor in this project is to understand how to create knowledge. And there are lots of interesting things we have already discovered, such as how do you recognize that a story in the African Times has significance, has historical significance, okay? That kind of information is not written down anywhere. And we have been picking Trevor's brain on what it means to have a significant original significant story. And it has given us a lot of interesting theories about how we can help people to be creative. Okay, so one of the things that we learned is that we really have to be able to extract the tacit knowledge that experts have about these topics. Because at the top of the pyramid, when we are doing curation, the work is based on a lot of experience, and a lot of that information is not written down. So if we want to automate it, we really have to create a tool that we can work with the experts and collect kind of the expertise so that we can actually do things that are creative. Okay, so this has been a very exciting project so far. And Sina is going to talk about the next project.
And the African Times was available in digital form, so we had to run text extraction to extract it. But it turns out there are thousands of other corpora in the form of newspapers, handwritten reports, and all these things would be potentially we will be able to work with them with AI systems and extract knowledge from them. The only limiting factor is that we don't have access to their text, so all these retrieval based models and an AI system won't be able to work with them that easily. So this one is a French corpus, is documents of basically travel logs of these steamships that would travel from country to country, from coast to coast, and they would write reports. This is some of the challenges here is that these are in tabular form, and this is not a regular structure for a document. And sometimes you have these kind of odd, unusual structures that you have to be able to deal with them if you want to work with their text. So specifically for this project, we will be working with this very large set of newspapers that the Library of Congress has. They have been scanned, and for example, this is one from the Titanic. I think it's right after it happened, so I think early 20th century. And this is one of the examples that they have, and you can see that the structure is kind of complex. You have a title, you have these small titles, and then you have columns, and you have images. So this is kind of very challenging for existing systems to be able to work with extracted text from, and so on. In fact, the Library of Congress also runs OCR and makes the text available. So this is an example of a text for this section. If you can read that, is their OCR here says 100 of telephone rails and telegraphic inquiries, something into the office, question mark, way last night asking information as T. So it's kind of like, some of the words are there, but a lot of it is also, extracted incorrectly. So this is actually very useful, but useful if you want to do keyword search. So if you search for Titanic, for example, it will show you this article, but then you have to read through it and hundreds of other articles about the Titanic to, make your own conclusions. So what we're proposing to do in this project is to use all these new technology that's, for example, 224V has very good vision capabilities that we actually used to extract the text from the African Times newspaper. But you want to extend that to be able to handle all these complex structures of newspapers, be able to break them down into smaller articles and detect where the images are, detect where the text is, and then be able to connect that to all these RAG systems like Storm that you have seen in your first assignment, and so on. So basically, you want to build a prototype, you want to evaluate it on, there are some benchmarks, and we also can look at them manually, and it will be very helpful. I think there is going to be, thousands, if not more, groups of scholars who are, working with these corpora around the world, and they are just ready to kind of work with these systems once they're available. Okay.
Does anyone have any questions? We still have Trevor here too, if anyone has any questions for
Yeah, I'm happy to answer questions. Well, I just want to say that, this is, for people working with the past, whether it's, economists or people working with, disease epidemiology in the past, or historians as we think of them, or whatever, this is really exciting stuff, and will really kind of transform how we can do this work.
Okay.
Hi, everyone. I'm Shi Cheng. I'm presenting the first project data talk on the proposal manual.
I'm Cheryl Phillips. I teach data journalism and computational journalism here, and co-presenting. So this first slide is a story that we did with the New York Times Investigative Reporting Fellowship, where we spent months trying to parse through contract documents and campaign finance contributions in the state of Hawaii. Basically, a fifth of the campaign contributions were tied to 15 companies that got big contracts from the state of Hawaii and from some of the counties, and that is just like a bare minimum of what's actually happening. That was the best we could do because we were doing this like using computational methods, using Python and doing OCR and doing all kinds of things. But the records were really bad. Sometimes they were non-existent, and there are just a lot of challenges. And so it took literally 100 plus hours. We had 3 different journalists working on it extensively for months. So I think the main point here is that investigative journalism relies on data. A lot of times data is something that takes a lot of laborious time, and some of the things you're doing in this class will help eliminate some of those time resources that constrain the ability to do really powerful and impactful journalism.
Thanks, Cheryl. So in this project, we propose to develop a data talk conversational engine. The conversational engine should be able to take in both graph databases, relational database, and free text, and be able to expose an interface for users to communicate with the agent. The core innovation part of it lies in a language we created that takes in both structured data and free text that augments SQL, which we call SUQL, stands for structured and unstructured query language. So with this language, what we could do is, instead of having the journalist doing all these 100 plus hours of navigation, the agent will be able to answer questions pulling from both structured data and unstructured text. So we have actually built a prototype for this that everybody can access at datatalk.genie.stanford.edu. Right now, the agent uses election data published from FEC and Open Secrets, and it gives you up-to-date information on questions you can ask about your senators or your House of Representatives. It does this by going in a agentic approach. It explores the database, as you can see on the top part, that it has intermediate thoughts. It presents the SQL, it explains the SQL to you, it gives you the result with links to the FEC website, then it also suggests some follow-up queries. We also built a navigation engine, so if you click on this, you should be able to pop to the right-hand side where people can share queries and share public dashboards. As I was just looking at the presentation, there has been much more shared queries that just came up, and everybody can look through them and get insights.
That's because my journalism class is using this, and we're working with 3 or 4 different newsrooms to publish stories right now, like in the next 2 weeks, up to the election. So there's real possibilities in being able to use this kind of platform or tool to be able to level up small newsrooms to be able to do important journalism. We think there's room to do more beyond FEC data, beyond just structured data, as Xicheng mentioned. And so one of these are just a few of the examples of census data, open elections data, campaign finance data from the state of California, and also Agenda Watch. I'm going to talk a little bit more about Agenda Watch. So Agenda Watch is a platform that we built. I run an organization here at Stanford called Big Local News. It's a data sharing platform and collaborative in support of local journalism. And we've also built this platform called Agenda Watch. Agenda Watch scrapes local government agendas and minutes from across the country. Right now, it's very much, I wouldn't even call it beta, it's alpha, but it's we have a couple of hundred agencies in there right now. We have built the scraping infrastructure. We think we're going to be moving up to about 3,000 agencies very soon, within the next couple of months. And it allows you to keyword search. So you can search across the agendas and minutes and look for patterns, homelessness, pedestrians, bicycles, certain company names, you name it. There's a lot more you could do with it if you used an agent. So I'm going to hand it back to you. Oh, I guess, this is an example of how you can do journalism out of it that's actually even more accountability focused, investigative focused. One of my classes last year took the Agenda Watch corpus for Santa Clara County, and we got the contracts for ICE. That ICE has contracts with all kinds of local governments, even though there's a sanctuary law in California that prohibits them from data sharing. The Santa Clara County was continuing to ink new contracts, pay more money to ICE, and sharing data with ICE at the same time that in their public meetings they were saying they were not doing that. So it was a really great way to link these two disparate sources of information to show kind of how they were, how the county was not doing what they were supposed to be doing.
Great. So in this research, we'll expand on a prototype and tackle a lot of more problems. Some of the problems that we're encountering is how do we automatically evaluate. We think simulations with users would be a good way to go. We also would like to building a fact that what Monica was talking about with task and knowledge. We'd like to be able to continuously improve the agent through more user testing and gather more knowledge about the data set that was the goal. So at the end, we aim to enable journalists without AI knowledge that can bring up the Datatalk Navigator very quickly and be able to get insights from it. That's it. Thank you.
I was wondering, I don't know if this is on or if it needs to be, like for the ICE example, like what information did you have to know about it before getting all that information about Santa Clara County and the ICE? Like, did you have to know that there was maybe potentially something suspicious going on, or did the computer like come up with that for you?
We just wanted to see where ICE contracts were in the state and see if there was potential for a story there. So it was a little bit of an exploratory mission. So we just grabbed all the ICE contracts and we thought, let's just see which county has the most ICE contracts. And it was surprising that San Diego was not surprising. It was number one because they have facilities down there. But second was Santa Clara County, which was a little surprising. It had the most contracts of any other county, and they were almost all data sharing. So.
So for next two projects, so just like one question, have everyone finished their homework one right now? How's Storm and CoStorm? Anyone want to share some insights or experience using it? Perhaps some bugs you find, some like, yeah.
One thought I had that I thought could be useful now is because it's so good at pulling information from different articles, using it to get candidate profiles for elections really quickly could be super useful, especially with the upcoming presidential election.
Good idea, good idea. Anyone else? No? Okay, yeah.
I tried to prompt it to use certain domains for its sources, and this is, I believe, a feature Complexity has, but it's like, if I want to have like good reviews for a restaurant, I don't want to look at news articles, I want to look at other people, so I want to prompt it to go on social media. I think that would be really useful.
Like the system will have the awareness of like users' preferences over the sources where the user can explicitly specify the sources, right?
Yeah, and like Perplexity has it so like if you want to search only academic articles, then it only searches the domains that are like scholarly articles. Search social media, you can search a lot of different types of websites.
Yeah, that's cool. So right now, like just before the lecture, we see that there are over like 160 topics collaboratively contributed by all of you, like across like more than 20 domains. Like some of them are present here. And we see a lot of good feedbacks, and thank you for all of your feedbacks and contributions. So if you wonder like what Storm and CoStorm does, like if you just want a comprehensive service from scratch that you want to spend minimal effort and want to know everything, something about everything, Storm can do it, right? And if you want to do an open-ended exploration assisted by AI, and you can like drive the conversation directions with the AIs, then CoStorm can do it. And I would just want to show a Twitter I spot this morning. Andrew Karpathy posted a Twitter post saying that the input optional product is something that's really interesting to people. Like because like coming up with a good input is really hard and become a barrier to many like AI products. And so allowing the users to see the system autonomously driven and occasionally like played by the users to steer the directions of the AI system will be a good directions for all the like AI products in the future. So like kind of CoStorm resonates with this philosophy to some extent. But like cold storm and storm doesn't like cover everything we want in the knowledge curation or satisfy all the information needs. So what if we want to write something about like plan a trip, plan a 7-day, 5-day trip to some places? And what about like write literature, survey, or related works of the academic work you are working on? And what about like doing investigative journalism questions, just like the George presented in the previous slides? All of them contain some shared perspectives, which is like they're all goal-oriented like information search, which is not like quite open-ended. You have a goal in mind, and the output is usually like structured in a certain way. So for example, if we're planning a 5-day trip in, for example, in Arizona, if you just use storm or cold storm, it will show something like this. Like it will survey like national parks, will survey potential activities and some trips, like tips about the travel and something else, like just everything. But if you just instruct it to like, could you summarize all the points here and give me a like 5-day trip itinerary? It doesn't like do it very well to some extent, especially if you want to be in the loop, saying that I want to modify the second day to explore, to be more like indoor activities. And then Storm hopefully it can modify the itinerary like to that part only while keeping all other parts intact. So this kind of structure awareness, planning aware language model system is not like really there in Storm and Cold Storm right now. So can we design a system to achieve this? And could we possibly include the human in the loop? And that is the project 1, which is planning with the AI. We're doing like human AI collaborative writing on the how-to articles. So we're going to, in this project, we're going to survey like existing methods, like the language model chatbots, Storm, Cold Storm, how do they perform on this type of task? And we're going to conduct proof of concept design and potentially conduct the automatic and human evaluation on such system. Any questions so far on this one? Yeah.
I understand. It would essentially be trying to align an LLM chatbot to output a certain type of text or text style.
It's not exactly the text style. You can imagine like after some search, if you just prompt the language model, given the Storm article, just instruct it to give me an itinerary, right? It probably do a decent job. But what if you want to interact with the system more? Talking about like, I don't like your planning on this day. Could you modify that? And I want to include more like indoor activities on day 3. Could you like go out search and then incorporate your result in day 3? Like this kind of, you have a clear outline structure of the output and you want to modify some of it. And even if you want to collaborate with the language model to modify the overall structure, current language system doesn't really do a good job at this one. Yeah. Any more questions on this one? All right. So the next one is an example investigative journalism writing. So for example, if you're going to write a topic about like PAC contributions to candidates for the US elections this year, this is kind of the outline you will expect from the Storm system. Basically, it surveys like many like background information and pull out information sources from the general internet. But if you take a close look at this section, like talking about the 2024 election here, some of the sources are even pulled from like 2023 or 2022. And some of the sections you see here is very general. It lists some general like categories, but not all of them. So if you want to write a very comprehensive, in-depth analysis of like a specific event or a specific angle about this report, the Storm doesn't like really go in depth, but go in breadth about everything. So you may wonder, like, this is just a few of them. Could we have like all of them? Could we include accurate data from untrusted sources into the writing? And if you even take a closer look at what are like the storm system does in the background. Like when you click on the See Brainstorming Process button in the website, you can see like the perspective guided QAs, and you see their questions. They're pretty like, in general, it doesn't like ask in-depth questions about specific data. Could you give me a list of all possible available like categories? It doesn't ask questions like that. So we're thinking, can we design a language model system that asks this type of question, that ask a very specific question that require like output of accurate data from the data sources or the databases? Just like what we presented in the previous one, the Data Talk project, it will like convert this kind of search queries into like program search queries here, and then augment the generation with the accurate result from the database and write an in-depth, comprehensive report, like in combination with the storm system. So the second project we're proposing here is having a deep dive, like on the, so conduct in-depth analysis with the knowledge curation systems. We're going to figure out like, can we design a database retrieval module and integrate that with the storm system? And can they combine, have a good performance on the use cases like the investigative journalism? And if necessary, if we have to design the in-depth question asking modules to instruct the language model to ask in-depth questions to these retriever modules, and we conduct the evaluations. So, any questions on this one? No? Okay, then I'll hand it over to next one.
Any of these projects interesting to you guys? Yes? No? Okay, I see some hands, so that's good. And if you guys are interested, you know who they are, you can contact them.
Thank you, everyone. It is a great honor to be able to present our pitch for the project here. I'm a software engineer at Sony Interactive Entertainment, as you know, PlayStation, and I'm coming with my coworker Michael Stoppa here, and he is the academic manager here, who's in charge of this academic relationship collaboration. Yeah, so let's just dive in. Let's think about this. So have you? Yeah, thank you. Let's take a minute to think. Have you ever experienced, or have you ever heard of anyone around you experience that the frustration when they try to push through a game, but they spend hours playing, like trying to beat certain boss or trying to solve certain puzzles, and that is the starting point of this project. So our proposal is to try to create a game tutor bot that could potentially help the user to go through these struggles. And it may sound a little bit vague to you that what does it mean, a game tutor, right? And let me break it down step by step so that it may be a little clearer for you how to achieve this goal. So let's think from basic. What does a game tutor needs to do if it's going to help a user to play a game? So fundamentally, the game tutor, it needs to know how to play the game, right? So that's the basic function. That's step one. And the game tutor will be able to, supposedly will be able to be dropped into any random gameplay scenario and be able to play the game episode by itself. That's the first step, the first level of feature that we would be looking for. And then comes to the second level of the feature. So let's imagine you play the game and I play a game. We might play the same game, but in a different game playing style. So for example, some people, they prefer to collect all the collectibles or try to just explore the environment in the game, right? But some people, they prefer to just go through the checkpoints and then reach the goal as soon as possible. So different players, they have different gameplay styles. And that will be the second level of the feature that we are looking for, which is to have this game tutor that are able to understand different gameplay styles according to the, for example, player history or just player inputs. And they can cater to the need of the player regarding that specific gameplay style. And there can be more features adding on that, but the third level feature that we will be happy to have is to have the game tutor to be able to deliver a instruction that's catered to the user's specific requirements of the granularity. So, for example, sometimes I'm in a more adventurous mood. So I would prefer that the game tutor to give me instructions that's more high level and just tell me strategic wise what I can do to go through this struggle instead of wasting hours trying to solve it by myself. But other times, I would prefer the game tutor to just tell me down to very specific which button I should push, I should press to just get through this hard, for example, boss fight. And those can be changed just based on this, even if it's the same player, right? So those will be the third level of feature that will be good to have in a game tutor. That we would love to we would love the game tutor to be able to cater to the player's requirements specifically. And those are the three layers of features that will be good to have for this project. And it might sound a lot for you, and it is a lot. Even each single individual feature itself is a hard research problem. So please don't push yourself to try to accomplish all, but try to focus on any one of those. And just for the presentations or the projects earlier that's been presented here, some of those could be potentially helpful for accomplish this goal. And after talking about the features, then I would like to just briefly talk about the simulation environment and the data that we could use. So unfortunately for this class, PlayStation won't be able to provide the real game or the player data due to the privacy concern. So we encourage you to look for any open source environment, game simulation environment, or any open source game data that you could find. And we don't want to limit your creativity on this. And we also provide some of the reference of the environment on the game project document. So hopefully Monica can share that with you, and feel free to refer to those if you would prefer. Last but not least, we look forward to you joining us. And if there are good results coming out of this collaboration, we will be happily continue for the future. And also, hopefully, we will be able to publish some research paper together. Thank you. Yes.
Yeah, thank you. This is a very interesting feature. According to your description of the feature, does it require some level of interoperability between the games and their account systems, or you think this feature is based on one game? Interoperability of because you mentioned it should be able to understand different games and the gaming style history.
Yeah, sorry, I forgot to mention that. And very good question. That is one key point here. So we all talk about large multimodal models, and we don't talk about it because it's popular. We talk about it because it's useful. So we encourage you to leverage the capability of these multimodal models, like LLM or LVM or whatever else that you could find to try to build this interpretability between the user and the agent. Yeah. Very good point. Thank you. Any other? Okay.
I was just going to ask, is there a specific type of game, different categories, RGP or FPS, or just any type of game?
Just any type of game, yeah.
Okay, cool.
Thank you.
Wait, sorry, just a brief follow-up to that. By any type, does that include the difference between single-player and multiplayer games, or only thinking about single-player games?
Yeah, either a single player or multiplayer. But multiplayer, there will be a next level of complexity. Yeah, so it's up to you.
I just wanted to ask, like, what are the current efforts at Sony in like implementing this, and has it been like implemented as in like certain games or like in like tutorials or anything?
So currently, the PlayStation it has some game tutorial, but those are pre-recorded videos by other players or by like community shared videos. So those could be your source if you're able to gather your own data. But unfortunately, we won't be able to provide those data. Yeah. So, thank you. Any other questions? Yeah.
Thank you so much. Thank you. Which one do you want to go first?
An example of this is how, let's say a knowledge corpus like Wikipedia is created, or if you look at the entire internet as a whole, how it's created, or let's say even a software documentation. So there are a lot of different people over a long period of time. In the case of Wikipedia, maybe 20 years, more than 20 years. And each person only looks as a small part, and it's gradually they add on top of each other to create this corpus of knowledge that search engines and large language models then use. But if you want to find inconsistencies, especially at this scale, you will run into some interesting cases which you want to tackle in this project. So let's say there's a simple statement, factual statement. Professor Monica Lam is a professor at Stanford University, and I want to see if there's anything else in the knowledge corpus that can contradict this. Now, I could search for this, for example, but what I would find is that the statement turns out to look inconsistent because there's another person with the same name as the professor who is not the person you're looking for. So basically, it is at the surface level, it looks inconsistent because you have different people. But in fact, if both of these people have Wikipedia pages, which they do, there's no problem there. Another example is, within Wikipedia, for example, you can ask under specified questions, like when was the first Harry Potter book published? You have to specify which country, and then even if you do that, in the case of Iran, you have to specify which calendar system you're using. So that's not a typo, it's just a different calendar system. So if you have an automated system just reading Wikipedia, trying to find inconsistencies, this would look like a problem that would be a false positive. So as I mentioned, we're working with Wikipedia as a knowledge corpus, and by the end of the quarter, we ideally want to be able to just run the system, build the system first, but then run this on the entire Wikipedia on more than 6 million articles, and find these pieces of information that this piece of information from this article actually contradicts this other one. Maybe one of them is outdated, maybe one of them is actually incorrect, or maybe they are using different measures of the same thing. And so on and so forth, and just have a list of this to be able to add that to the public for the public use. And there are cases where you can fix them. There are cases where you have to refer to a human or a Wikipedia volunteer to fix these things, and that would be very helpful. So obviously, if we have a prototype, it uses GPT-4 to break down documents into claims and compare them across different documents, but there are some interesting challenges when you want to scale that and when you want to add all these nuances to it, which we will be working on this quarter. So any question for this project so far? Okay, and feel free to contact me, by the way, about any of these projects if you're interested. So another project that I'm proposing is trying to build systems that can analyze or answer very deep questions about what is being reported in the news, which is also in its own term a reflection of what is happening in the real world. So there are many use cases. In fact, an interesting use case is for organizations that want to collect data on, let's say, humanitarian crises that are going on around the world. They want to prepare, they want to inform governments how to prepare, allocate resources, or journalists who want to report on, let's say, the war around the world, the number of casualties, and what can be done to help people with those situations. So one of these organizations is called ACLED. We actually just published a paper with them this morning. And it is basically, the paper goes over how can we build automated system using LLMs that take the code book, take the definitions of what is of interest to them. For example, let's say they want to look at, have a map of all the striking locations in Ukraine during the last year. So, the way we can do this is we build the system and then we run it on, every available news article that we can find, especially in other languages, especially in Ukrainian and Russian in this case, and probably English. And you find all these locations from these systems, and then we can have these high-level analysis on what is going on and how it can be reported and how the situation can be improved potentially using this data in some way. So it is actually a difficult task. So ACLED, for example, has 200 people around the world looking at news reports in different languages with a high accuracy to try to be able to put these data reports together so that other people can use in a reliable way. But there are a few things that we think we can do to help further than just automating or trying to automate and trying to help with that. One is, what if we want to let users ask any question, not just about conflicts, not just about political conflicts, but let's say a question is how are news media reporting in Canada about American sports teams? That's just a very random question. Or you can ask about news reporting bias. You can ask about the topics they cover or anything like that. So, but all these questions could be answered using the system that looks at individual articles, millions of them, in fact, and then tries to extract something from each of them and put them together. So for this project, we will have the code for this paper ready. It's basically has this base system that works with conflict data. We want to expand it, and also we have this clean corpus of 600 million news articles from the web, covers the last 8 years in 100 languages. So it's a good test bed for all these language models, their multilingual capabilities, and how we can extract information at scale and make them useful for people. So any questions for this one?
people can hear me now, that could basically answer questions grounded in data, which is something that this class highlights a lot. And so the goal of this specific project now is to build a similar system for KQED's audio archives. And we want to make this interactive, and we want to leverage new techniques, which we've seen in this class, like SU, SQL, Storm, hybrid search and RAGs, and other things, and just build on top of this existing audio transcription pipeline. And just a little bit of background on KQED. It's the largest public radio station in the U.S. They have 45 weekly programs and podcasts, and they have a bunch of diverse content. And you would have access to all this data, which is really cool because you can sort of directly apply this data into your project. And just to highlight some of the key project components, you're working with LLM embeddings on audio and trying to categorize content and diarization. So, when there's a specific name that might be mentioned in a news article, like a radio station, you want to be able to segment that name and correctly output it. And on top of that, enhancing the retrieval system. So building like a hybrid vector search with dense and sparse vectors, building knowledge graphs, maybe even a re-ranking system. And then another goal would be to make sort of each specific thing feel curated to that specific radio station. And we have some examples of this, which I won't get into right now. And just some challenges and considerations to highlight are handling diverse content types, ensuring accuracy, especially in temporal cases. So if I ask a question that might have an outdated answer, you don't want to output that. So you have to really have like a lot of metadata to avoid those things. And also just gracefully acknowledging limitations of the system itself. You also get to work with domain experts, Steve Henn, who is at Stanford Big Local News. He also teaches the computational journalism class. He's at NPR, and also Lowell Robinson, who's at KQED. So that's the first project. Any questions? Okay. The next one I'm going to go over is, again, it's going to be an audio transcription pipeline, but this is specifically for sort of answering questions about lectures like this recorded one right here, and being able to interactively deal with the transcription archives. And so just the overall project statement here is, right now, lecture notes are one-sided. This is a recording right now. You can listen to it later, but you won't be able to really search over the content very well or get answers to the things that were talked about. There's, in general, just a lack of interaction between anybody who's going to watch this later. And there's a highlight on the importance of active engagement and learning, so being able to interactively communicate through the archives. So the project goal itself is just to create a conversational agent that takes video/audio transcripts of lectures as input, and being able to sort of create a question-answer system grounded in the data itself. And really, there's an emphasis on making sure that you bring up the accurate transcription content. And you also want to incorporate additional study materials that might be relevant to the course, which could be things like the textbook, syllabus, notes, etc. And specifically, we're going to prototype this conversational agent from Stanford Med 275, from diagnosis to dialogue, which is taught by Professor Brian Lin. And we're going to build it specifically for this podcast to start, but I think the goal should be to be able to do this for any sort of lecture that Stanford might have. And just a couple of things to highlight, you'll get to build on an existing structured audio pipeline and integrate lecture content, additional materials, and again, try to deal with domain-specific errors. And this is my contact information. Thank you. Is there any questions on this one?
Will students still come to class after this?
Hopefully they will. Hopefully they will. Yeah.
Have you experimented with using any synthetic data to help these agents out? Because I assume because text-to-speech is okay, and I assume getting all these lecture videos and the ground truth it would be quite difficult, especially for mathematics, where you're not going to have law tech for every math lecture.
Right. Yeah. I mean, I think it's kind of the reverse, like speech to text, right? So you're going to transcribe the audio into text, and I think the initial goal is you really want to ground it in what it's said, right? Because LLM has all sorts of information, and the goal is to specifically sort of parse, the chunks that you transcribe and bring the most relevant ones forward. But of course, like there's totally room for hallucination, right? I ask a follow-up question and sort of like that isn't in the context of this class, the LLM still has knowledge that's external, and you want to make sure as tightly as possible to sort of ground against that. Yeah, that would be the ideal case. All right, thank you.
So, hey everyone. I'm pitching a couple of projects which are related to the Genie worksheets work that we have been doing. So all of you are aware of OpenAI. They have their ChatGPT and everything. You would expect them to use AI, like LLM-based agents for, let's say, helping you out with any issue. But if you go to their customer service, they still have a dialogue tree-based chatbot where you have to interact with you have to click on these different buttons, and then they have these different dialogue flows. And this kind of illustrates how challenging this problem is, that for all these transactional dialogue agents, like how do you reliably create them? How do they interact with the users? So I want to highlight 3 challenges. So the first one is, how do you create these effective agents, but by providing developers ease of like coding these up? So people use LangChain guidance and Autogen kind of libraries to create these chatbots, but it requires a lot of effort. You have to create ad hoc pipelines. So this is one of the key main challenges in creating these reliable agents. Then the second one is that the agent should support composition of query languages and like task information. So if the user is providing you some information, they also might want to gather some information from different knowledge sources. So these agents should be able to respond effectively to these queries while also performing the task. And then the third problem is, as the conversations become longer and longer, keeping track of the important fact in the conversation becomes more difficult. So here's an example. Let's say so this is the scenario of Course Advisor, where the student initially says that I want to take some AI course for letter grade and for 4 units. And then the user interacts with the agent exploring different courses. Let's say there are like 15 different courses, talking about the ratings, the reviews, and everything. And eventually when the user says that, oh, I'll take, let's say, math theory for ML course, the agent should know that the user wants to take this course for a letter grade and 4 credit of units. So this, again, like keeping track of such long conversations becomes problematic with if you're just purely using LLMs. So our Genie worksheet, the developer has to provide APIs, some examples, and there's a high-level specification, which you'll read about in the assignment that we'll release today. You just provide this to the agent. It has different modules with help with semantic parsing. They help with agent policy and then generating the response. And you get a conversational agent where the user can talk with the agent. They can like gather information and complete the task. So we did some quick evaluation. This is on one of the static data sets. So traditionally, all these static data sets for conversation task-oriented agents, they were just like slot filling, where you just have to do slot filling. You have a JSON file, you have fields, and you just fill out specific values. So we show that in like such academic data sets, Genie outperforms the state-of-the-art methods. But then we also conduct a real user study where we had 62 users and we had 3 different agents. One was for restaurant reservation, one was for ticket submission, which is similar to like ServiceNow kind of agent, which helps you like file complaints, and then the course enrollment bot. We gave the users we gave a set of user GPT-4 with function calling, creating the whole pipeline, and other set of users, Genie, and then we evaluated them across execution, the dialogue act accuracy, and if the users were able to complete the goal or not. So the last row, you can see that for ticket submission and course enrollment, our system like just outperforms GPT-4 by a lot. But this is not all. We have multiple. So this is just the beginning of the project. There are like several other projects that we want to branch out from this. So the first one is trying out new application domains with Genie worksheets. One of the application domain could be FAFSA, where undergrad students, they have to like file for student aid. This process is very difficult. You have to gather a lot of information. So this could be like one of the application domain which you can use. You can bring your own application domain. The other one is like I talked to a few people. They said that they also want a module in Genie Worksheet where the LM can ask questions on its own. So when you want to dive deeper into some conversations, there should be some module which controls when to ask from this, let's say, the specification that we have versus with the LM. So this could be another interesting project that one can work on. Then there are a few other things, such as how can we use worksheets for creating web agents, because you have to like store information, you have to store what actions you took previously, and can we use that and like use the context handling mechanism that we have to create such web agents. And then there's another one which is like kind of like more of a improvement over Genie worksheets, which is using some sort of an agentic approach which performs semantic parsing and then also improves the response generation quality and handling errors. And finally, there are like some, like if you're interested, we can also work on how do you actually evaluate these systems. So for this study, we had to conduct user study, but you cannot always conduct user studies. So if there could be, so we can work together to find out like what are the ways of automatically evaluating such systems. Thank you. If you have questions, let me know. Okay, there's one more slide. Please fill out your Together AI credits form by end of day today. We'll send the accounts to Together AI tomorrow. And it's on Ed, just fill it out. And because tomorrow we'll send it to them, and after that you won't, like if you haven't filled it out, you won't get the credits. Thank you.
We're going to do today. So here's the plan for the next week. There's a lecture on Monday, and then on Wednesday, we're going to have an open mic system, okay? Maybe you're looking for project partners. Maybe you have some ideas that you just want to pitch to your fellow classmates and get their feedback. And so let us know. We're going to have a sign-up sheet, and we can kind of run this kind of thing around, again, but this time with you guys get to talk. All right? Okay, I'll see you next week on Monday. Thank you. Thank you to all the speakers.